Bismillahirrahmanirrahim. Assalamu alaikum. I am Dr. Fazullah. And in this lecture, we shall get the concept of zeros and singularities for a complex function. So let us start from the topic zero. So first of all, we have to define that what we mean by the zero of a function. We say that a point z0 is called a zero of a function f of z if f of z is analytic at z0 and f of z0 is equal to 0. From my previous lectures, you know that what we mean by an analytic function. So a function f of z is called an analytic function at the point z0 if it is differentiable at the point z0. So first of all, this function must be differentiable. Now if we are given a function f of z and I have to put some value inside this function and I get an answer which is exactly 0, then z0 is called a zero of this function. So let us explain it by some examples. Let there is some function f of z which is equal to z minus 1. If I put z is equal to 1 in this function, I will get f of 1 is equal to 1 minus 1, which is equal to 0. And this implies that z is equal to 1 is a zero of the function f of z. Now let us see another example. I take a function f of z which is equal to z square minus 3z plus 2 divided by sine z. Sometimes we are given a function like this one and we have to find the zeros of this function. Then what we have to do? In that case, we have to put the numerator equal to 0 and then we have to factorize it. So the roots of the numerator are called the zeros of this function. For example, let us do that. Put the numerator which is equal to z square minus 3z plus 2 equal to 0. Now let us factorize this thing. So if I factorize, I will get this thing. Let us take common. So I get z minus 2. If I take common as minus 1, I will get this thing equal to 0. And from this we obtain that z minus 1 into z minus 2 equal to 0. So this implies one point I get from this one, which is z is equal to 1, and the other point I get from this, which is z is equal to 2. So z is equal to 1 and z is equal to 2 are two zeros of the function f of z. Now if we put z is equal to 1 in this function, f of 1 must be equal to 0. Similarly, if we put z is equal to 2 in this function, f of 2 must be equal to 0. So now let us generalize this definition a little more. So we have to write another definition These are called simple zeros, and now I have to find the order of zeros. So I have to define that a point z0 is called a zero of order k of the function f of z. If f of z is analytic, at z0, and if I put z0 inside the function, I will get 0. Now if I differentiate this function and I get f dash of z and put z0, I get that this is equal to 0. Similarly, if double dash of z0 is equal to 0 and up to if k minus 1th derivative at z0 is equal to 0, but the kth derivative of the function at z0 is not equal to 0, then this is called that z0 is a zero of order k, where k is a non-negative integer. So let us explain it by some examples. Let us take a function f of z is equal to z minus 2 power 3. And now we can see that if I put z is equal to 2 in this function, I will get that f of 2 is equal to 2 minus 2 cube, and the answer must be 0. Now I have to differentiate this function. So if I differentiate, I will get f dash of z is equal to 3 into z minus 2 whole square. And if I put z is equal to 2, I will get that f dash of 2 is equal to 0. Now let us differentiate it again. So f double dash of z is equal to 6z minus 2 power 1, and if I put z is equal to 2, I will get that f double dash of 2 is equal to 0. And now let us differentiate it again. So if triple dash of z is equal to, from here I can get only 6. And now if I put z is equal to 2, the answer is 6, which is not equal to 0. So this implies that z is equal to 2 is a 0 of order 3 of the function f of z. And now we have to solve another example. Sometime we are given a function and we have to find its 0. So let us solve another example. The example is, I have a function f of z which is equal to cos z minus 1 and plus z square divided by 2. The question is that show that z is equal to 0 is a 0 of this function, and find the order of the 0 for this function. So what we have to do? You can see that if I put z is equal to 0 here, cos 0 is 1. 1 minus 1 is 0 and this is 0. So f of 0 is equal to 0. So it is clear that z is equal to 0 is a 0 of this function. But I have to find something more. I have to write the series expression of this function, which we know from the Taylor series. So I can expand this function like this one. F of z is equal to, cos z is equal to 1 minus z square by 2 factorial and plus z4 divided by 4 factorial minus z6 divided by 6 factorial and plus up to so on. So this is the series expression of the cos z, and now I have to write minus 1 and plus z square by 2. And now you can see that 1 should be cancelled with 1 and minus z square by 2 factorial will be cancelled with z square by 2 because 2 is equal to 2 factorial. So I have the function that f of z is equal to z power 4 divided by 4 factorial minus z power 6 divided by 6 factorial and up to so on. Now if I put z is equal to 0 in this function, if I put z is equal to 0, let this is 1, then from 1 I can write that f of 0 is equal to this is 0 and all will be 0. So I get that f of 0 is equal to 0. Now I have to differentiate this function. So f dash of z is equal to, this is 4z cube, but 4 will be cancelled. 4 factorial means 4 into 3 factorial. So from this I can get that z cube divided by 3 factorial if you simplify. Similarly from here I can get 6z power 5 divided by, I can write this 6 into 5 factorial. So this should be equal to z power 5 divided by 5 factorial and plus up to so on. And now if I put z is equal to 0 in f dash of z, then this is 0 and this is 0, so the answer is 0. Now I have to differentiate it again. F double dash of z is equal to, from here I can get in the same procedure z square by 2 factorial. And from here z power 4 by 4 factorial and plus up to so on. And now if I put z is equal to 0 in f double dash of z, I will get 0. Now I have to differentiate it again. So if I differentiate it, I will get a triple dash of z is equal to, here I will get only z. This is actually 2z divided by 2 factorial, but they will be cancelled, so we will get only z. And minus z cube divided by 3 factorial and plus up to so on. And now if I put z is equal to 0, I will get that this is equal to 0. So I have to differentiate it again. If I differentiate it again, I will get that this is 1, and from here I get z square divided by 2 factorial plus up to so on. And now if I put z is equal to 0 here, I will get 1. So if I put 0, I get 1 which is not equal to 0. So this implies that z is equal to 0 is a 0 of order 4 of the given function f of z. Now let us define the singularity of a function f of z. So we say that a point z naught at which a function f of z is not analytic. Is called a singular point. Or singularity. Of a function f of z. A function is not analytic, means a function is not differentiable at that point. So let us explain this by some example. I have a function f of z which is equal to 1 over z minus 2. Now let us differentiate this function. If I differentiate this function, I will get minus 1 over z minus 2. Now if I put z is equal to 2 here, you will get that f dash of z is undefined. Like you can see, it is very obvious that f of 2, this is 0, anything divided by 0 is undefined. So it means that f of z is not differentiable at this point. And this implies that f of z is not analytic at the point z is equal to 2. So hence z is equal to 2 is a singular point. Is a singular point of the function f of z. Now let us see some more examples. Let us write f of z is equal to log of z, and let us find its singular point. So now again we have to differentiate this function. F dash of z is equal to 1 over z. Now if I put z is equal to 0 here, so anything divided by 0 is undefined. So it means that f dash of 0 is infinity. So the function f of z is not differentiable at the point z is equal to 0. So hence it is not analytic at the point z is equal to 0. And this implies that z is equal to 0 is an analytic. This is a singular point of the function f of z. Now let us consider one more example. In this example, let us take a function h of z which is equal to 1 over z square minus 9. Let us consider this function. And if I differentiate this function h dash of z, so by the differentiation I can get that the denominator square z square minus 9 whole square. And now I have to write z square minus 9, differentiation of 1 is 0. So this term is 0. Now I have to write minus 1, and differentiation of this thing is 2z. So I will get that this is equal to minus 2z divided by z square minus 9 equal to whole square. So sometimes we are given a function, this one, and we have to find its singular points. In that case, we have to differentiate the function, and then we have to put the denominator equal to 0. And the root of the denominator must be singular points. So let us put z square minus 9 whole square is equal to 0. And this implies z square minus 9 is equal to 0. And from this we can get that z minus 3 into z plus 3 is equal to 0. And if we further simplify this, we will get that there are 2 points, z is equal to 3 and z is equal to minus 3. And these 2 points are the singular points for this function. If you put 3 here, you will get infinity. If you put minus 3 here, again you will get infinity. So this function is not differentiable at these 2 points. So it is not, so these 2 points are the singular points of this function. And now let us discuss some types of the singularities. So types of singularity. There are basically 2 types of singularities. The first one is called isolated singularity, and the second one is called non-isolated singularity. But the isolated singularity is further divided into 3 types. The first one is called removable singularity. The second one is called poles, and the third one is called essential singularity.